Okay, my name is David Garland, and I'm with the Highlanders FRC team. So today I'm going to be showing you how to develop CNC parts using CREO and export the CNC code to run them on your CNC machine. So here we go. Okay, so here is our part. This is the CNC mill part that we made on our CNC mill. So if you look, it is an aluminum 2x1, and all we did is we milled one face, flipped it over, and did an identical procedure on the back. So here is how we made our part. So to begin with, we have our sketch. That's the basis for the entire part. So if you look at it, it is basically just a rectangle that we formed out the inside. And all we do is we extrude it, simply 1 foot. Then what we do is we make another sketch. And this is the sketch that defines our truss patterns. So all this sketch is a very relatively simplistic collection of construction lines and actual geometry that we use to form our rounded corners and the triangles that our part is made out of. So this is simply extruded all the way through the part, forming our CNC model. So we then take this part and we move it into our CNC assembly, and this is where we define the actual operations that the CNC mill is doing. So to begin with, we added our part, and then we defined the part that we have to begin with. Now the part that we have to begin with is simply a 2x1, so it's everything that this part is, except that the trusses are filled in. So it's simply an extruded 2x1 rectangular piece of aluminum. So after that, we go in and we define what our milling machine is. So for this case, we have a tree milling machine. We define a post-processor, a number of information about the milling machine, and that's pretty much everything that there is about the milling machine. We then define our milling window. Now the milling window is a fairly straightforward item, and it simply says where the milling bit will travel. So the milling window is actually just this plane extruded only slightly more than this face, so as to get maybe a little bit of the scallops that are below this face when we're done with the machining. And the milling window could encompass the entire part, it could encompass more than the entire part, and it could be of any depth that we want it to be, making it a very flexible tool. We then define our coordinate system. The coordinate system for most of our parts is always at the back right-hand corner, so if the machine is oriented like so, with the machine back here and the part lying like this, the X, Y, and Z are going to be facing in those directions. We add our operation. This is a collection of information regarding our clearance plans, parameters such as the coordinate system that we're basing this off of. For example, this is our clearance plane. It tells where the machine is to retract to after each machining step so as not to destroy the part when moving between operations. And a number of information about our fixture and how this part is set up. Now, since we don't need any of that information for this part, this is not actually in there. If this was more complex setup, we would have included our fixture setup. Anyways, we leave that as is. And now we go into our actual cutting operations. So this is more complicated, but all you have to do is you right-click, Edit Definition, Sequence Setup, and you select what you want to change. In this case, we're just going to go ahead and look at our parameters. And we might as well look at our tool as well. So we hit Done, and it pops up with the tools we have available. We've already defined 3 tools that we can use. We defined their diameters, what kind of tool they are, and their numbers and IDs. This is where you can specify the type of the tool, and in this case this operation is using tool 1 in this case. It's selecting tool 3, but we're actually using tool 1 for this operation. So the tool 1 has the diameter of 0.48 inches and a number of other useful information. Material, high-speed steel, inches, 2 flutes, some fairly straightforward information. So we can cancel on that actually. And then we go back to sequence setup, go back to our parameters, hit Done, and now we can look at some basic information about what the cut's going to be doing. So our cut is going to do a feed rate of 20 inches per minute. This is our depth. This is how far it cuts down each time. That's roughly 0.05 inches. It has its tolerance, how much is stepping over each time it's doing a cut, and how much we're leaving for the next number of passes to operate with. So in this case, we're leaving 0.02 inches to work with. Type 3 is our scan type, in which case it's going to run back and forth around the part. There are a number of other options. This just is the most efficient for this type of operation. Climb mill, we're only roughing, we're not doing profile cut, and spindle speed 2000. Spindle speed isn't particularly relevant, but we have it anyways. So done sequence. These are all 3 finishing passes, and they're all roughly following the same template, so we'll just look at the last one. This is the final finishing pass. It uses tool 3, our smallest tool, and we can go and look at our parameters. So yet again, cut feed to 20. Step, everything is pretty much the same as it was before. We'll do a little bit more of a step, but the pass before this leaves about 2 thousandths left to work with, and this operation is going to cut all that 2,000ths away and give us our final part. So in this case, we're doing a profile only. Climb mill, type 3 scan type. Scan type isn't particularly relevant in a profile operation, but we leave it there. Spindle speed, and really a ton of other options. So we can hit OK, and we can hit done sequence. Now all these operations are as they should be, and if you want to check your part before running it on the CNC machine, a great way to do this is actually go to CREO. You right click on your operation, which contains all your actual cuts, and you hit right click, play path, and if you just hit this little button, we want to slow this down maybe a tiny bit. We'll check what we want later. So as you can see, it's doing a scan type operation. Sorry, this is a little bit hard to maneuver. It's going to run over, sort of running around, going down, running around, going down, and doing this. It's going to do this for all the triangles, and this is using our biggest bit. Now we can speed this up, sort of run through all these operations, and it's going to show us where it retracts to. So this is our medium-sized bit, and it's going around and it's doing some secondary finishing operations. So it's going to go in, and finally we're on our smallest bit, and the smallest bit is going to run over all these once and then do it again, because the smallest bit actually has two finishing operations. The medium-sized bit's only used once for a single finishing operation, and the biggest bit's used once for the primary roughing operation. Now, if we know that this is something that we want to use on the CNC machine, we can just stop the operation, and we can actually go to File, Save as MCD, and you go Save CL File also, and you can click Output. So in this case, we're just going to call it op01. We can call it a number of things, but we'll just leave it as that. CREO is going to do a number of operations, and it's going to ask us what our post processor we want to use this. In this case, we have set up, this is our post processor, UNCX01.P01. We just select it, CREO does all its stuff, it gives us a log, and it tells us we are good to go. So we leave the part as is, and now you can put this on your CNC machine and run it. So your post processor will depend on your CNC machine, and usually you can get it from the manufacturer. In this case, we got it from some very helpful people who work with the software that we use to program our CNC mill with. So yeah, that's pretty much the entirety of how to make a CNC milled part in CREO. And this is how our FRC team did it. So thank you for watching, and live long and prosper.